Bismillahirrahmanirrahim. Dear students, we discuss oxalic acid now. Dear students, let's start. First of all, key concepts. Key concepts consist of introduction of oxalic acid, history of oxalic acid, structural formula of oxalic acid. Then we discuss preparation of oxalic acid from sodium formate, preparation of oxalic acid from propylene, preparation of oxalic acid from oxidation of glucose. After this, we study chemical reactions of oxalic acid. First, we study reaction of oxalic acid with oxygen, then acid-base reaction. Then we discuss reaction of oxalic acid with CHEM2113, decomposition of oxalic acid. After this, we study reaction of oxalic acid with ethyl alcohol, then reaction of oxalic acid with ammonia. Then after this, reaction of oxalic acid with phosphorus pentachloride, reaction of oxalic acid with ethylene glycol, and the last one we discuss heating of oxalic acid. After this, we discuss importance of oxalic acid and then uses of oxalic acid. Last one we study harmful effects of oxalic acid and summary. Introduction of oxalic acid. Oxalic acid is the chemical compound with the IUPAC name ethane dioic acid. Oxalic acid is an organic compound with the formula of C2H2O4. Organic compounds are generally any chemical compounds that contain carbon. Due to carbon's ability to catenate, that is form chains with other carbon atoms, millions of organic compounds are known. Now, the study of the properties, reactions and synthesis of organic compounds are known as organic chemistry. A few classes of carbon containing compounds, that are carbonates, cyanide salts, carbon dioxide, etc., are not classified as organic compounds and are considered as inorganic. Oxalic acid is a white crystalline solid that forms a colorless solution in water and is also known as a dicarboxylic acid. Introduction of oxalic acid. The dicarboxylic acid is an organic compound containing two carboxyl functional groups COOH. For example, malonic acid, succinic acid, glutaric acid, adipic acid, etc. For molecules with two carboxylic acid groups, the carbon chain in between the two carboxylic groups, including the carboxyl carbons, is as the longest chain. The suffix dioic acid is used. The general molecular formula for dicarboxylic acids can be written as 2CO2H attached with R, where R can be aliphatic or aromatic carbon. Dicarboxylic acids show similar chemical behavior and reactivity to monocarboxylic acids. Dicarboxylic acids are used in the preparation of copolymers such as polyamides and polyesters. The most widely used dicarboxylic acid in the industry is adipic acid, which is a precursor used in the production of nylon. Other examples of dicarboxylic acids include aspartic acid, glutamic acid, and 2 amino acids in the human body, etc. The name can be abbreviated to diacid. Oxalic acid is a reducing agent and its conjugate base is called as oxalate ion, which is the formula of oxalate ion is C2O4 2-. Reducing agent, also called a reductant or reducer, is an element or compound that loses or donates an electron to an electron recipient, that is called oxidizing agent in a redox chemical reaction. A reducing agent is thus oxidized when it loses electrons in the redox reaction. Now continuing the introduction of oxalic acid. Oxalic acid is a chelating agent for metal cations. And now what are chelating agents? Chelating agents are chemical compounds that react with metal ions to form a stable and water-soluble complex. They are also known as chelants, chelators, or sequestering agents. Chelating agents have a ring-like center which forms at least 2 bonds with the metal ion, allowing it to be excreted. What is chelation? Chelation is a type of bonding of ions and molecules to metal ions. It involves the formation or presence of 2 or more separate coordinate bonds between a polydentate ligands which have multiple bonds and a single central atom. These ligands are called chelants, chelators, chelating agents, or sequestering agents. Ligands are usually organic compounds, but this is not a necessity. As in the case of zinc and its use as a maintenance therapy to prevent the absorption of copper in people with Wilson disease. Wilson disease is a genetic disorder in which excess copper builds up in the body. Symptoms are typically related to the brain and liver. The most widely used dicarboxylic acid in the industry is adipic acid, which is a precursor used in the production of nylon. Other examples of dicarboxylic acids include aspartic acid, glutamic acid, and 2 amino acids in the human body, etc. The name can be abbreviated to diacid. Oxy is meaning sharp, acidic suffering to the acidity common in foliage of certain plants from which it was first isolated. In botany, the term foliage refers to either a collective canopy of leaves made up of many plants or an individual tree or plant's grouping of leaves. In simple words, foliage is simply a grouping of leaves. Oxalic acid is commercially available as the dihydrate containing 28.5% of water. It is a monoclinic prism, particle size varying from fine powder to coarse granules which are also colorless. Melting point is 187 degrees centigrade of anhydrous form and 101.5 Celsius of dihydrate form. Oxalic acid is one of the most widespread organic acid in plants. Oxalic acid occurs as the dihydrate with the formula of C2H2O4 with two water molecules. Oxalic acid is naturally occur in many foods, but excessive ingestion of oxalic acid or prolonged skin contact can be dangerous. Shelley in 1776 discovered the oxalic acid. Its name is derived from the Greek word oxys, meaning sharp, acidic. It is a transparent, odorless and colorless crystal. Its boiling point is between 149 to 160 degrees Celsius. Commercially, it is available as dihydrate, which is in crystalline form with two water molecules attached to each molecule of oxalic acid. In terms of acidic strength, it is about 3,000 times more stronger than acetic acid. Now the formula of oxalic acid. You can see the structure of oxalic acid. At left side, two carboxylic groups attached to each other and are called dioic acid or diacid. In this slide, you can see on the right side the Lewis structure of carboxylic acid. Now the preparation of oxalic acid. First of all, preparation of oxalic acid from sodium formate. Oxalic acid is usually prepared by heating sodium formate with sodium hydroxide to form sodium oxalate, which is converted to calcium oxalate and treated with sulfuric acid to obtain free oxalic acid. Dear students, as you can see in the equation, sodium formate reacts with sodium hydroxide at 375 Celsius temperature to form sodium oxalate with releasing of hydrogen. This sodium oxalate again reacts with calcium hydroxide to produce calcium oxalate with two molecules of sodium hydroxide, which is also called as caustic soda. Calcium oxalate again reacts with sulfuric acid to generate oxalic acid plus calcium sulfate. Preparation of oxalic acid from propylene. Oxalic acid is produced by absorbing propylene in strong nitric acid and then heating the solution while removing the oxides of nitrogen formed, preferably after introducing oxygen into the solution. As you can see in the equations, one propene reacts with hydrogen nitrate or nitric acid to produce 2-nitropropanoic acid with release of water molecules. 2-nitropropanoic acid, when reacts with oxygen, it forms oxalic acid with hydrogen nitrate, nitrogen dioxide and water. In this way, from propylene we can get the concentration of oxalic acid. Preparation of oxalic acid from oxidation of glucose. This is a laboratory method. Oxalic acid can be prepared by oxidizing sugar using nitric acid in the presence of vanadium pentoxide as catalyst. As you can see in the equation, C6H12O6, a sugar reacts with 6 molecules of hydrogen nitrate or nitric acid in the presence of sulfuric acid at 60 centigrade temperature with pentoxide catalyst to produce dihydrate oxalic acid with 6 molecules of nitric oxide. Now the chemical reactions of oxalic acid. First of all, we discuss reaction of oxalic acid with oxygen. Oxalic acid reacts with oxygen to produce carbon dioxide and water. As you can see in the equation, oxalic acid reacts with oxygen molecule to produce 2 carbon dioxide and 2 water molecule is also released. The other reaction is the acid-base reaction. Oxalic acid is a weak organic dicarboxylic acid, and sodium hydroxide, which is also known as the caustic soda, is a strong monoacidic base. The reaction between them is said to be base neutralization reaction, in which water molecule is released. Oxalic acid reacts with 2 molecules of sodium hydroxide to generate sodium oxalate with water molecule. Chemical reactions of oxalic acid. Now, reaction of oxalic acid with potassium permanganate, KMnO4. Potassium permanganate, which is an oxidizing agent, reacts with oxalic acid in aqueous sulfuric acid according to following equation. As you can see in the equation, 5 molecules of oxalic acid reacts with 2 molecules of potassium permanganate with 3 molecules of hydrogen sulfate to produce potassium sulfate with 2 manganese sulfate molecules plus 10 carbon dioxide and 8 molecules of water. As you know, KMnO4 oxidizes oxalic acid to produce carbon dioxide and water. Now, reaction of oxalic acid with methyl alcohol. Dimethyl oxalate can be obtained by esterification of oxalic acid with methanol using sulfuric acid as a catalyst. As you can see in the equation, oxalic acid reacts with methyl alcohol in the presence of sulfuric acid to produce dimethyl oxalate with 2 water molecules. Esterification is the process of combining an organic acid with an alcohol to form ester and water. It is a chemical reaction resulting in the formation of at least one ester product. So, ester is obtained by an esterification reaction of an alcohol and a carboxylic acid. It is a monoclinic prism, particle size varying from fine powder to coarse granules, which are also colorless. Melting point is 187 degrees centigrade of anhydrous form and 101.5 Celsius of dihydrate form. Oxalic acid is one of the most widespread organic acids in plants. Oxalic acid occurs as the dihydrate with the formula of C2H2O4 with 2 water molecules. Reaction of oxalic acid with ammonia. Oxalic acid reacts with ammonia to produce ammonium oxalate. Ammonium oxalate again heated to form oxamide with the release of water. Oxamide is the diamide derived from oxalic acid. As you can see in the equations, oxalic acid reacts with ammonia to form ammonium oxalate, and when this ammonium oxalate again heated, it forms oxamide with the release of water. So the next reaction is reaction of oxalic acid with phosphorus pentachloride. Phosphorus pentachloride react with oxalic acid to produce oxalyl chloride, phosphoryl chloride, and hydrogen chloride. Hydrogen chloride is also known as hydrochloric acid. This reaction takes place at a temperature of 80 to 90 Celsius. As you can see in the reaction, oxalic acid reacts with phosphorus pentachloride to produce oxalyl chloride plus phosphoryl chloride plus 2 molecules of hydrochloric acid. Oxalyl chloride is a chemical compound with colorless, sharp smelling liquid. The diacyl chloride of oxalic acid is a useful reagent in organic synthesis. It can be prepared by treating oxalic acid with phosphorus pentachloride. Now we discuss reaction of oxalic acid with ethylene glycol. Reaction of oxalic acid with ethylene glycol. The other name of ethylene glycol is ethane 1,2-diol, results in the formation of a cyclic compound called ethylene oxalate. In this reaction, you can see that oxalic acid reacts with ethylene glycol or ethane 1,2-diol to produce ethylene oxalate, which is a cyclic compound, and release of water molecule. Heating of oxalic acid. Oxalic acid crystals are nothing but dihydrated oxalic acid. The formula of oxalic acid is H2C2O4 with 2 water molecules. On heating, the water of crystallization is lost first. Then the dehydrated oxalic acid decomposes into carbon dioxide, carbon monoxide, and water molecule. In this equation, you can see that dehydrated oxalic acids, when heated on 373 to 378 Celsius temperature, it is converted into oxalic acid and releases 2 water molecules. And when dehydrated oxalic acid on heating, it composes into carbon dioxide, carbon monoxide, and water molecule. It is a monoclinic prism, particle size varying from fine powder to coarse granules, which are also colorless. Melting point is 187 degrees centigrade of anhydrous form and 101.5 Celsius of dihydrated form. Oxalic acid is one of the most widespread organic acid in plants. Oxalic acid occurs as the dihydrate with the formula of C2H2O4 with 2 water molecules. Introduction of oxalic acid. The dicarboxylic acid is an organic compound containing two carboxyl functional groups COOH. For example, malonic acid, succinic acid, glutaric acid, adipic acid, etc. For molecules with two carboxylic acid groups, the carbon chain in between the two carboxylic groups, including the carboxyl carbons, is as the longest chain. The suffix dioic acid is used. The general molecular formula for dicarboxylic acids can be written as 2CO2H attached with R, where R can be aliphatic or aromatic carbon. Importance uses of oxalic acid. Oxalic acid main applications include cleaning or bleaching, especially for removal of rust. About 25% of produced oxalic acid is used as a mordant in dyeing process. It is used in bleaches, especially for pulpwood, an important reagent in lanthanide chemistry. The lanthanide series of chemical elements comprises the 15 metallic chemical elements with atomic numbers 57 to 71 from lanthanum through lutetium. These elements, along with the chemically similar elements scandium and yttrium, are often collectively known as the rare earth elements. They are called lanthanides because the elements in the series are chemically similar to lanthanum. Both lanthanum and lutetium have been labeled as group 3 elements because they have a single valence electron in the 5d shell. Oxalic acid is also used in the restoration of old wood. Its reducing properties are utilized in platinotype, the early photographic palladium printing processes. A platinum print is a monochrome process based on the light sensitivity of iron and platinum salts. Vaporized oxalic acid or a 6% solution of oxalic acid in sugar syrup is used by some beekeepers as a miticide against the parasitic varroa mite. And what is miticide? Miticides are substances that kill mites. And what is varroa mite? Varroa mite is an external parasitic mite that attacks and feeds on the honeybees. The disease caused by the mites is called varrosis. We discuss harmful effects of oxalic acid. First of all, oxalic acid is poison. Those with kidney disorders, gout, rheumatoid arthritis, or certain form of chronic vulvar pain, also known as vulvodynia, are typically advised to avoid foods high in oxalic acid. The calcium oxalate crystals are precipitate, better known as kidney stones, because most part of the kidney stones formed by the calcium oxalate. It can obstruct the kidney tubules. An estimated of 80% of the kidney stones are formed from calcium oxalate. Oxalic acid is corrosive to body tissue. When ingested, Oxalic acid removes calcium from the blood. Kidney damage can be expected as the calcium is removed from the blood in the form of calcium oxalate. This calcium oxalate then obstructs the kidney tubules. Now, what are the impacts of oxalic acid on our health? Number 1. Oxalic acid corrodes tissue. Inhaling is harmful and it may result in severe irritation. Ingestion of it results in renal damage. Renal means kidney damage. In contact with skin, severe itching and burning sensation prevail. Its eye contact may result in corrosive effect. Chronic exposure may lead to inflammation. Oxalic acid removes calcium in the blood, forming calcium oxalate and severe damage to kidney. It has a harmful effect on environment due to pH shift. Now the summary. Oxalic acid is a comparatively strong organic dicarboxylic acid. It is a ubiquitous substance in mammalian tissues and plants. It is endogenously produced in humans. Plant food constitutes the major source of dietary oxalic acid. Now the oxalic acid is used in woodwork. Oxalic acid is also used in textile industry. It is also used as a disinfectant. Oxalic acid is occurring naturally in honey. Oxalic acid used in textile industry. It also used as a disinfectant. Oxalic acid is occurring naturally in honey. Thank you.